G'day, Jeff. How you going?
Hey, Stella. Long time no see.
Quite some time. Quite some time indeed. But the weather's still there, and it's still weathering. So, what are we going to talk about today on Whether or Not?
We are going to look at a ISSR, which is ice supersaturated region, showing where it originated and where it is right now. What you're seeing on the screen is the satellite view of the southeastern US, where you could see the lines in the sky in blue. You can see up here in Tennessee, a whole bunch of them. You could see parts of Mississippi, Alabama, Georgia, and the whole panhandle of Florida, as well as parts of Louisiana, are getting this influx of clouds from the Pacific Ocean, giving the conditions for contrail formation. I'm going to show you all the tools that we use to assess that. So this is what you see. The satellite, my internet will not support this, so I went and recorded it. I'm going to back up to the recording here and start it past Mexico, to the southwest of Mexico, where that batch of cloudiness associated with the jet stream and its high clouds, which is cirrus clouds, and watch it come in. And then I'll comment on the other parts that go along with it after that.
All right.
Ready?
Okay, far away.
Okay, here we go. So you could see that streaming in from the southwest came from the Pacific. And that big picture I showed you live was where this is right now. And later I'll try to go into the future for the rest of the day as it continues to the east. So now the supporting information. So there was the situation for the skies for 35,000 feet to 40,000 feet. All the bright yellow ones are those that are in that area of the sky. And that's the altitude of the aircraft that are flying through that area of the world.
35 to 40,000 feet.
Correct.
Okay.
So you're talking 11 to 13 kilometers-ish for the people that like kilometers. All right, now we're going to go to radius on data. So first of all, Jackson, Mississippi.
You've just clicked on where the radio sonde was launched. Is that correct?
That is correct. Jackson, Mississippi, and that's the
Okay.
that's the red line. That's the temperature line, and the blue line is the humidity line.
All right, that's the radio sonde chart. Okay.
Correct. So when those lines get close together, like the 3 or 4 points in there, that means you have clouds in that area, as opposed to when they're really far apart, like right here, that means no clouds. So every time they get close together, and this right here, I'm going to back it up a little bit here, where I first put the cursor on that, because I'm relying on a recording right here to make this smooth. So that's 31,000 feet where they get when they get really close together. That's the first area clouds are possible.
So temperature and dew point are very
Correct.
close in relationship to each other. Okay.
Right. And up here, you could see that red line does an abrupt turn to the right.
Yes.
That's the top of the troposphere, bottom of the stratosphere. Ozone is up in the top area. That's heating up from the rays of the sun, and that's a stable layer. It stops clouds from going up. The humidity drops off rapidly to the left, and you get that really widespread. That's how you can tell when you're in the stratosphere. That's up at the level of, let me put this guy right there, 41,000, 40,000 feet. That's the start of the stratosphere.
Okay, well, that's really good to know. So that sudden inversion that you see on the radio sonde data chart is always where the stratosphere happens. Correct. Because it gets warmer and drier. So therefore we see the inversion on the chart.
Perfect.
Okay.
Okay, so we know the area between 300 and 200 is where aircraft fly. So I'm going to show you the numerical data that goes with that. I'm going to pause that right there. and show you the numerical data that was used to draw those graphs.
All right, so this is another way of looking at the same data, but a numerical version. Okay, sorry
Correct.
to interrupt there. Just wanted to get that out.
The flight stratum for aircraft is between 300 and 200 millibars. This is almost dead center of that flight stratum. And that's 11,000 meters area. That's what that second column is.
Okay.
Third column is the air temperature. Fourth column is the dew point. Fifth is the percent humidity. And then the sixth is the weight of the water in that area at that level, 0.12 grams per kilogram. Then you have the wind speed and direction, which says west at about 36. So I'm going to pick out the highest moisture content, which is 72%, and 50.3 degrees negative Celsius. And
Temperature.
then, yep, and I'm going to plug that into a calculator. And I'm going to put, this is done by Mick West, and it's going to figure out a value of 118.1, which shows it's 118% saturated. It's oversaturated, which means you're going to get a really persistent contrail. At 100%, you're going to get a contrail that starts to persist. The higher you go above that, the more persistent it becomes. So we're well into oversaturated with respect to ice crystals. Does that make sense?
Okay. So basically, what we're saying here is today, which is the 17th of November in America, if people walked out right now, they would be seeing a bunch of lines in the sky, and they would have seen them this morning because that's the video that we took. Yeah.
Yes.
So today was a heavy contrail day, chemtrail, whatever you want to call it, sea trail,
Sea trail. That's what I like.
plane farts. Thank you, Jim. There's going to be a lot of them out there today, so it's good to note because not that I go on Facebook, but I'm sure there's probably a few photos floating around at the moment going, they're spraying us today, they're spraying us again. So we just thought we'd point it out that there's actually a reason.
It's
That
a
there's
spray
lines in
day.
the sky. Yeah, government's back on. Anyway,
So
let's continue.
the reason why that is because you have that band of moisture coming in from the Pacific Ocean,
Hmm.
and that provides moisture that can get you to either cloud or not cloud at the edge, and then you add burnt kerosene, which injects water vapor, and that adds to that moisture, and that can bring it up into the saturated region where you see a line in the sky, a contrail, chemtrail, sea trail, because of that moisture that's already there, that ambient moisture from the clouds.
Yes, and that happens to be at exactly the right altitude for where a lot of the planes are flying. So that mix all together
Dead center.
produces trails.
234 millibars, minus 50 degrees Celsius, and 72% humidity at the highest. So
Okay. Well,
moving on to the windy app right here.
okay.
So I'm going to go ahead and play that right there and let it go through. And this is the contrail finder. And I'm going to go ahead and click it over to high clouds. And then I'm going to look at the different weather models and click on that area of the world. And every model displays it slightly differently. You can see this one's showing 37 to 39,000 feet. That's the ECMWF model. The GFS, if I click on that same area, it's showing a slight difference, 37 to 41,000. Then the icon model, you can see the cloud changes. That's the predictions for where that clouds are going to be. And this is from 35 to 39,000 feet. Last but not least is the HRRR model. And that shows, let's see, 36 to 42,000. So there's a consensus that they all say there are going to be contrails
All right.
amongst all of them with slight differences in altitudes. But for the most part, they all agree that the upper 30,000s will bring contrails.
Well, that does make sense considering you guys are heading into your what you call fall. So it's those sort of conditions are pretty much expected, aren't they? Getting a little bit cooler up there in the sky.
As you get the colder temperatures and the more frequent weather fronts coming through, you're going to see, like if you look farther to the north, you got up in Salt Lake City, there's a circulation center right there. That's a low pressure center. There's a cold front up there.
Mm-hmm.
You keep on getting more and more clouds because that cold air is starting to come down from the Arctic, creating the
Right.
conditions. Uh, you always look at the front edge of the cloud bands, and that's where you're going to find the contrails, sea
Right.
trails, chemtrails.
Yep.
That's where we're seeing them, leading edge of this area coming in from the southwest.
Okay.
That's
And
the
why are we going to see them on the edges? Purely because they're not visible in the clouds once the clouds come over? Is that
once
as
you
simple
get
as that, or?
when that cloud band gets thicker, then any jet exhaust that goes into the middle of a thick layer, say it's 5,000 feet
Yeah. Okay.
thick, it's just going to become part of the cloud. You're not going to see it if it's really thick.
Yep. And also there was some drone footage that shout out to Ian, I think it was Ian, that brought some drone footage to the Telegram group recently, which was a drone actually going through some clouds and then up above the cloud and seeing some trails, which I don't know what that footage was meant to be representing, whether it was, see, they're spraying us above the clouds where we can't see them, or whether it was somebody going, hey, check out what my drone just saw. Isn't it great? Or I don't know, but that is how it works. Like, I mean, I was in a plane just recently, and it's just amazing. You go through all this cloud, and then you go up above the cloud, and it's a completely different world. There's different things happening because there's all different things going on at different altitudes. So, yeah, it kind of makes sense that things are going to be different at different altitudes. So when people look up and they sort of see that cloud, that plane's leaving a trail, whereas that one's not, and they're at the same altitude, you can't really say that because you can't tell whether they're at the same altitude just by sight. Even somebody who's very learned can't do that. Pilots even can't really generally do that.
If
So,
you're looking at even the weather observations from the professional weather observers, which are only found at the major airports, when they're looking at cirrus clouds, usually they say 25,000 feet
mm-hmm,
for the
mm-hmm,
altitude. And most of the time in the summer, it's 30, 35, 40, sometimes even 45, but they put 25,000 because it doesn't really matter to most people.
yep,
Even the weather
yep.
observers, they put 25,000 scattered or broken or overcast.
Yeah, and if somebody's looking up at a couple of planes, they could be 1,000 feet apart, which means they could be in a completely different atmospheric situation. So they could be well and truly doing something completely different, like one leaving a trail and one not. So that's about right, isn't it? Like 1,000 feet can make a big difference. Yeah.
It's exactly right. When you go back to this part where that showed the differences in between the models, you know, right here it's saying 36,000 feet is the
Mm-hmm.
starting point. It's telling you need minus 48. The actual temperature is minus 49 expected to be with this weather model. The humidity is above 100%, so it gets a check mark. And that
Right.
continues all the way up there till it drops to below 100% relative humidity with respect to ice.
Mm.
Once
And
that
so,
drops to below, you get no check mark.
gotcha. So the check marks are the the persistent contrails, according to that chart, which is found on windy.com. Anyone can go there. You don't have to have a paid subscription to see that. I don't think, do you? Contrail plugin, do you?
You do not have to have, mine's set for premium. but
Yeah.
you can get the contrail finder without. Let me jump to Wendy and just show
Yeah.
you where that is. So up here, you got the X mark, and you click on the X. I might just open a new tab. There we go. Contrail
Yeah.
finder is right there.
Yeah, which is a plugin you've got to request. It's not just there.
Correct.
Yeah.
Up here where it says install Wendy plugin, if you don't have it, that will be there. And then you select it from a list, and that gets you to this point, and it's got a user's guide as well. And I like clicking it to high clouds first, because that shows the different weather models and what the differences are at that time. So you can see that area has progressed to the east to the current time. Everything's jumped farther to the east since when I recorded that earlier.
Yes. You go to the high clouds because that's basically what we're looking for.
Exactly.
That's
And
where
you
the
can,
temperature and dew point will be correct for the situation.
Correct. And every single weather model, as earlier, you could see they all differ somewhat.
Yes.
That's just
Because
everything's moved.
science just can't agree on anything, can they?
Different algorithms, different groups of scientists coming up with the numbers for the weather model.
That's only a handful of models. There's actually lots and lots of models. But,
there's even more.
Bad bunch, I think.
I'm only showing 4.
Yeah. Okay, well, I think that pretty much wraps up what we were trying to show. We won't get into any more weeds on this episode.
Tennessee. At dark, they had contrails in the northeast.
Yeah, well, that sort of shows what people need to kind of keep their eye on. Look for the high clouds, look for the altitudes that the planes are flying at, and then go onto Windy and have a look at, well, your nearest radio sonde, near the problem area, let's call it, and see what the altitude and the temperature is. And you might find that everything comes together in a beautiful recipe for a contrail or a chemtrail, whatever side of the fence you happen to be on.
Well said.
Sea trails are where you just sit on the fence. All right. Thanks for that, Jeff. We do appreciate you showing us the science behind the realities. So
Very
appreciate
welcome. It's fun. Thank you.
All right, and thanks to everyone that tuned in, and we really hope that you've learned something from that. I always learn something every time I talk to Jeff. He claims to have a map with a legend, but I claim that he's a legend with a map. So on that note, we shall depart. Until next time.